Good day to all the viewers. My name is Nodi Yambo. Welcome to today's lesson, which is all about cells and batteries for the grade 8
Technical Studies B
learners. A battery is a container made of cells in which chemical energy is converted into electricity and used as a power source. Upon that background, this lesson will examine the components of different types of cells and batteries.
The lesson objectives are to explain how cells and batteries are a source of electrical energy, differentiate between primary and secondary cells, describe the difference between the types of cells by identifying the components of cells and batteries, and to list the advantages and disadvantages of cells and batteries.
Now that we have our objectives, let's get into today's lesson.
Cells and batteries. Electric cells refer to devices in which chemical energy is transformed into electrical energy. This action is not changeable in primary cells. However, secondary cells can be recharged repeatedly by passing a current through them in the opposite direction to the current flow during discharge. Two electrodes of different types of materials, an electrolyte, and positive and negative terminals or poles that are connected to the external circuit are regarded as the vital components of both a primary cell and secondary cell. In order to differentiate between the two terminals on the battery, the terminals are marked positive and negative. This marking also prevents confusion. A motor vehicle lead-acid battery's positive terminal or pole is larger than the negative terminal. A positive terminal or pole is marked with a red color, while the negative terminal is marked with a green or blue color. Primary cells. Once primary cells are assembled, they can produce current. Batteries that are not reusable are also known as primary cells, meaning primary cells are only intended to be used once and then thrown away. Primary cells are usually used in movable devices. Examples of these disposable batteries are zinc-carbon batteries, mercury, silver oxide batteries. Usually, disposable batteries or primary cells are regarded to have higher energy densities than rechargeable batteries or secondary cells. However, the disposable batteries or primary cells do not perform well under current applications. For example, a simple zinc-carbon primary cell, Lackland's dry cell, with a terminal voltage of 1.5 V. Secondary cells. Secondary cells should be charged before use. They are usually assembled with active materials in a discharged state. Rechargeable batteries or secondary cells can be recharged by connecting them to an electrical current, which reverses the chemical reactions that occur during their use. Devices that supply the appropriate current are called chargers. The most generally used secondary cell is the lead-acid cell used in motor vehicles. Lead-acid batteries consist of 1. A lead dioxide cathode, 2. A spongy metallic lead anode, 3. A sulfuric acid solution electrolyte. These metal elements make them toxic and harmful to environment. The cell voltage is commonly 2 V each. The composition of the different types of cells and batteries. Battery type, lead acid. Properties, 1. Have a lifespan of about 3 to 4 years. 2. Robust and reliable. 3. Deliver high currents. 4. Wide range of sizes and capacities. 5. Heavy and bulky. Uses: 1. automotive use, cars, buses, trucks, etc. 2. Lighting. 3. Uninterruptible power supplies. 4. UPS. 5. Submarines. Battery type, deep cycle. 1. Must be completely discharged before charging. 2. Have thicker and stronger plates than lead-acid batteries. 3. Can be charged many more times than lead-acid batteries. Uses. 1. Marine applications. 2. Golf buggies. 3. Forklifts. 4. Electrical vehicles. The advantage of lead-acid cell or batteries. 1. Relative low cost compared to lifespan. 2. Reliable over 140 years of development. 3. Tolerant to overcharging. 4. Low internal impedance or resistance to alternating current. Disadvantages of lead-acid cell or batteries. 1. Very heavy and bulky. 2. Danger of overheating during charging. 3. Not suitable for fast charging. 4. Typical cycle is 300 to 500 cycles. 5. Must be stored in a charged state once the electrolyte has been introduced to avoid deterioration of the active chemicals.
Viewers, now that we have come to the end of our program, let's recap on what we have learned.
In this lesson, we learned about cells and batteries as sources of electrical energy. We differentiated between primary and secondary cells. We described the difference between types of cells by identifying the components of cells and batteries. And we listed the advantages and disadvantages of cells and batteries.
Thank you all for joining us. Until next time, goodbye.